Hello. In this video, I'm going to find the volume of a solid region. The solid region is defined by a plane, which is a plane through the origin, and it's the part of the plane that lies above a region given by y equals x squared and x equals y squared. This picture here, which I'm drawing, is not, it's just not going to be that good no matter what I do. But essentially you have this plane. This plane, as you can see, when x equals 0, y equals 0, z equals 0, gives 0. Well, no. When x is 0 and y is 0, I get z is 0. So this passes through the origin. So x0, y0 gives z equals 0, so it passes through the origin. So you have some plane that goes through the origin. So already that's a little bit of a tricky business sketching that. But anyway, you have a plane that passes through the origin, and it lies above a region D. The whole thing's not going to come out that good if I draw it. But essentially, we're trying to, the plane lies above this region D. We're going to try to find the volume of that. Now, what I think I can do a decent job at is sketching the region D. So I might even give up on this one, to tell you the truth. What I do will be it just won't look that good. I don't even think a computer drawing would look that good, because you have to maybe be at the right angle. Just get something that looks nice. But let's just sketch this region D. So what is the region D? The region D is a region in the XY plane. And the way I look at these sols is it's like a little house, or something like that, or I suppose a sculpture or something. But we're going to have a region D down here, and in the XY plane, and then we have this other surface above, which happens to be a plane, and that's sitting up here, and we're finding the volume. See, terrible picture, but let's focus on y equals x squared. We can really get something good out of that. Y equals x squared is a good one. Okay, so get y equals x squared. You can plot a few points. I don't think it has to be super accurate, but then x equals y squared, sort of its cousin that's like super awesome, but people don't really know about x equals y squared. Yeah, well, I think a lot of people do, but should know about it. But anyway, there's x equals y squared. All right, the region D is the region bounded between these two, so I drew away more of the picture than I need. If I carefully sketch the graph for y equals x squared, I know that I have this point 1, 1, and that point also, and we have the point 0, 0. Those points also are, these are points that are on both of these, y equals x squared and x equals y squared. So this is our region D. And so you can sort of see why I had a little bit of trouble drawing this picture. I think I could do something that's okay. It's like D's like this. But that is the floor of our little house here. And then anyway, the what's above is a plane, and we're trying to find that solid. Okay, this region is type 1, and what does type 1 mean? Type 1 means that it can be described above by a curve, and that curve above is, well, see, this curve in red, as you can see, is x equals y squared, but we're trying to describe it, y as a function of x, so I'll write y equals the square root of x. And then below the region, we have y equals x squared. So type 1 means that the region is described above by y equals a function of x, and below by y equals a function of x. It's also, by the way, a type 2 region. We could express on the left y equals x, or x equals y squared, on the right x equals the square root of y. But this, I'm going to use type 1. We could use either way. So type 1 means that I have x, so it's a set of all x, y, and x is bounded. Okay, let's make this bigger. Okay, it's a set of all x, y such that x is bounded by two numbers, in this case x and 1, and y is bounded by two functions. Y is bounded by the function x squared and the function square root of x. We're going to integrate the square root of x, so I'm going to rewrite that as x to the 1/2 later. But this is how we describe a type 1 function. Y is between two functions of x, and x is between these two numbers. And our volume is equal to the integral over a region D of the function fxy. This is not a general formula for volume. A more general formula would be that you have a function that describes a surface, and that's above, and then you subtract a surface, a function that describes a surface, and that's below. So in this case, F would be like the ceiling or the roof of your house, and G would be the floor. But for our problem, the floor is just, this part here where I have D, that's in the plane Z equals 0. And the plane up here on the top is Z equals, well, that's a good point. What is the plane on the top? Here I have 3x plus 2y minus Z equals 0. So what I can do is pretty easily add Z to both sides. My y got sort of weird here. Okay, so that's our roof, and our floor is Z equals 0. So when I plug in this formula, I have the function fxy is 3x plus 2y. That's the one on top. And then I'm going to integrate the integral with x is from 0 to 1, put parentheses, dx, and then I have an integral with respect to y, which is y goes from x squared to square root of x, which I'll just write down as x to the 1/2. And that's dy. So a little bit small there. Maybe I need a finer pen to draw that, to write that, x to the 1/2. The integration is, sort of straightforward, but, well, maybe not entirely. You have to understand how to do partial integration. We're going to integrate with respect to y. So 3x is a constant. We integrate with respect to y. We have the constant times y. And then we have this part 2y squared. So I'll integrate with respect to y and get 2y squared over 2. And then super awesome stuff when you get cancellation. And then we go from x squared to x to the 1/2 dx. So I'll plug in the top and I'll plug in the bottom. The way I usually do this, though, is I go 3x and then I do y from x squared to x to the 1/2. And then I'll have y squared from x squared to x to the 1/2. That's just how I do it. So that's going to give 3x, x to the 1/2 minus x squared plus x to the 1/2 squared minus x squared squared dx. And this is just going to be a really straightforward integration then. So I feel like I didn't get that last parenthesis. So 3x times x to the 1/2 gives x to the 3/2 minus 3x cubed plus x to the 1/2 squared makes plus x minus x squared squared, so it's minus x to the fourth, all of that dx. And then I integrate 3x to 3 halves plus 1 is 5 halves, divide by 5 halves, minus 3x to the 4, divide by 4, minus x squared over 2, minus x to the fifth over 5, all from 0 to 1. So for this one, first one here, I have to multiply by the reciprocal of 5 halves. So I have 3 times 2 fifths. I just put in 1. Putting in 1, just everywhere I see x to any power, that makes 1. Putting in 0 makes 0. So I just put in 1. So I don't even have to write anything there. Minus 3/4, minus 1/2, minus 1/5. You know, my thing is this mistake that I make. I'm doing it all the time, apparently. Here's a plus. All of a sudden I make a minus. No particular reason. Something's wrong with my brain, apparently. I don't know what I'm doing, why I'm doing that. But minus, oops. Let's just double check I didn't do anywhere else. Minus, okay. Got the plus. And I have a minus. All right. So this gives 6 fifths minus 3/4 plus 1/2 minus 1/5. And 6 fifths minus 1/5 makes 5 fifths. And then, well, I bet I can do that in my head. Negative 3/4 plus 1/2. Let's just go with that. That's negative 1/4. So 1 minus 1/4 is 3/4. And that is the answer to this problem. All right, so the integration was, a little something, but not so bad. I mean, I don't know. It's not the very best problem for sketching the three-dimensional solid. It's a good problem for the, the region D. But yeah. So it's a pretty cool house. You got your sort of unusual floor plan there, your footprint, so to speak, D, and then the roof is coming up at a funny angle. So, okay, hold on. It's super bad for me not to label the axis. I got to do that for sure. That's X and Y. That's a really sloppy thing not to write that down. Okay, that's multivariable calculus. Takes a lot of concentration. It's good for the brain. I've heard people say that. Okay, that's all. Thanks, everybody. Like, comment, subscribe. That would be super great, wouldn't it? Just put a little like, a little comment, a little subscribing. Okay, bye, everyone.